Hi students, in this video I am going to do leftover solved problems and some exercise problems from 4B. Okay. Next, problem 4. If the normal at one end of the lattice rectum of the ellipse x square by a square plus y square by b square equal to 1 passes through one end of the minor axis, then show that e to the power of 4 plus e square equal to 1, where e is the eccentricity of the ellipse. Okay. Let us consider a greater than b case. Okay, similarly you can do for a less than b case. So we have a short and fat ellipse like this. Here is the one focus on x-axis. Lattice rectum will be the chord passing through S perpendicular to axis. This is the one lattice rectum. One of its end going to be this one AE comma b square by a. Okay, fine. If you look at a tangent at this end, it will be something like this. If we draw the normal at this end of the lattice rectum, it looks something like this. Okay, which is a line passing through this end and perpendicular to the tangent. Here, if it passes through one end of the minor axis, that is here, b dash 0 comma minus b, if this normal passes through this end of the minor axis, then we have to show that e to the power of 4 plus e square equal to 1. Okay, fine. First of all, let me write down this normal equation. We know that normal to this ellipse x square by a square plus y square by b square equal to 1 at a point x1 y1 on the ellipse is what? A square x by x1 minus b square y by y1 minus of a square minus b square equal to 0. Okay, so what is our choice of x1 y1 here? This end of the lattice rectum, that is ae comma b square by a. Okay, fine. Now we want to write down this normal at this point ae comma b square by a. So normal to x square by a square plus y square by b square equal to 1 at ae comma b square by a will be what? A square x by, what is x1? ae minus b square y by, what is y1? b square by a minus of a square minus b square equal to 0. Okay. Now this one we can write ax by e minus ay minus of a square minus b square equal to 0. Let me call it 1. Okay, this is a normal through this end of the lattice rectum. Okay, fine. Now what we know here, we know that this normal passes through 0 comma minus b. Okay, one end of the minor axis. Okay, here if this 1 passes through 0 comma minus b, see what happens here? A times 0 by e minus a times minus b minus of a square minus b square equal to 0. Okay, so we have ab minus a square plus b square equal to 0. Okay, in a greater than b case, the relationship between a, b and e is this: b square equal to a square times 1 minus e square. So if I replace b square with a square times 1 minus e square, now if I replace b square with a square times 1 minus e square, we will have this ab minus a square plus a square times 1 minus e square equal to 0. Okay, that implies ab, so here a square cancel. So we have minus a square e square equal to 0. That implies e square will be b by a. Okay, That implies e to the power of 4 will be b square by a square. Again, what is b square? A square times 1 minus e square. So e to the power of 4 equal to a square times 1 minus e square by a square. Here a square cancel. So here e to the power of 4 equal to 1 minus e square. So e to the power of 4 plus e square equal to 1. Fine. Next, problem 5. If Pn is the ordinate of a point on the ellipse, x square by a square plus y square by b square equal to 1, and the tangent at P meets the x-axis at t, then show that Cn times Ct equal to a square, where C is the center of the ellipse. Okay, here let us say this is our ellipse. Okay, so let us say this is a point on the ellipse. Let me take in parametric form p of theta, that is a cos theta comma b sin theta. Okay, any point in this ellipse must be in this form a cos theta comma b sin theta for some theta in 0 to 2 pi. Fine. Okay, the tangent at this P meets the x-axis at a t. Okay, so if you take a tangent at P, okay, it's meeting x-axis at a t. Okay, here Pn is the ordinate of the point P. So if you draw the perpendicular onto axis, x-axis, it meets the at a point N. This Pn going to be ordinate of the point P here. Okay. Now first let me write down this tangent equation at P. So tangent to x square by a square plus y square by b square equal to 1 at P of theta is x cos theta by a plus y sin theta by b equal to 1. Let me write down this tangent in intercept form. So let me write down this one, x by a by cos theta plus y by b by sin theta equal to 1. Okay, so here let me call it 1. Here the tangent 1 making x-intercept what? X-intercept equal to a by cos theta and y-intercept equal to b by sin theta. Okay. Okay. Here C is the center, right? So Cn is going to be abscissa of this point, that is a cos theta. Okay. Pn is the ordinate, that is b sin theta anyway. Okay. Here this Ct will be exactly equal to x-intercept of this tangent. Here this Ct will be x-intercept of this tangent. So Ct equal to what? A by cos theta, and Cn equal to what? That will be abscissa of this point P, that is a cos theta. Okay. Now if you look at Ct times Cn, that will be a by cos theta times a cos theta. Now this cos theta cancel, that equal to a square. Therefore we have Ct times Cn equal to a square. Problem 6. Show that points of intersection of the perpendicular tangents to an ellipse lie on a circle. Okay, that means here let us say if this is our ellipse, if you consider any two perpendicular tangents to this ellipse, they may be looking like this. This is a one tangent, another one should be perpendicular to this tangent, something like this. Okay, so the point of intersection, let us say P, x1, y1, this always lies on a circle. That means we have to show the locus of point P, which is intersection point of two perpendicular tangents to this ellipse, is a circle. Okay, fine. First of all, let me consider a standard ellipse equation. Let x square by a square plus y square by b square equal to 1 is a ellipse equation. Okay, let me call it 1. We know that any tangent to this ellipse 1, okay, we know that any tangent to this ellipse will be of the form slope intercept form y equal to mx plus or minus under root a square m square plus b square. Let me call it 2. Okay, now let px1 y1 be a intersection point of perpendicular tangents to 1, perpendicular tangents to ellipse 1. Then this point x1 y1 must lie on 2 for some real value of m. So P lies on 2 for some real m. Okay, fine. Then we must have y1 equal to mx1 plus or minus under root a square m square plus b square. Here m is some real number. Actually, there will be two values of m, say m1, m2, for which the corresponding tangents will be passing through x1, y1. And as we have taken x1, y1 intersection point of two perpendicular tangents, so these two m1, m2 represent slopes of these tangents must be perpendicular slopes. That means m1 into m2 must be equal to minus 1. Anyway, from this, so we can write down y1 minus mx1 plus or minus under root a square m square plus b square. If I take a square both sides, then we will have y1 square plus m square x1 square minus 2m x1 y1 equal to a square m square plus b square. Okay, now I can write down x1 square minus a square times m square minus 2x1 y1 m plus y1 square minus b square equal to 0. Let me call it 3. Okay, so here m1 m2, then m1 m2, which are slopes of the perpendicular tangents whose intersection point is x1 y1, must be roots of this quadratic equation 3. Then m1 m2, which are slopes of perpendicular tangents whose intersection point x1 y1 must be roots of 3. Okay, so what is 3? Quadratic equation m. Okay, so then what should be product of the roots? m1 into m2, that should be constant term by the coefficient of m square, that should be y1 square minus b square by x1 square minus a square. Okay, that implies actually what is m1 m2? Since m1 m2 are slopes of the perpendicular tangents, product must be equal to minus 1. So we should have minus 1 equal to y1 square minus b square by x1 square minus a square. That implies here we have minus x1 square plus a square equal to y1 square minus b square. Then we can write down x1 square plus y1 square equal to a square plus b square. Okay. Therefore, the locus of point P is what? X square plus y square equal to a square plus b square. This circle x square plus y square equal to a square plus b square has a special name, which is something called director circle of the ellipse x square by a square plus y square by b square equal to 1. The circle x square plus y square equal to a square plus b square is called director circle of the ellipse x square by a square plus y square by b square equal to 1. Okay. That means if you take any two perpendicular tangents to this ellipse, they meet on the circle. For example, if this is a one tangent, okay, if you take another perpendicular tangent, okay, they look something like this. See, they are going to meet on this circle. Okay, such a circle is director circle of this ellipse x square by a square plus y square by b square equal to 1. Fine. Next, problem 7. If a circle is concentric with the ellipse, find the inclination of their common tangents to the major axis of the ellipse. Here we have to find out angle that common tangent to the circle and ellipse which are concentric, making with a major axis of the ellipse. Okay, fine. Let the circle be x square plus y square equal to r square and ellipse be x square by a square plus y square by b square equal to 1. Both circle and ellipse we are taking in standard form. As you can see, both having center 0, 0, so they are concentric. Also, we are considering a greater than b case for ellipse. So here the major axis of the ellipse is x-axis. Fine. Now let me consider the case r less than b less than a. In this case, the circle will be entirely sitting inside the ellipse like this. In this case, we don't have any common tangent, so no common tangents possible in this case. Similarly, next case, if b less than a less than r, if r is bigger than a, then you see that this ellipse entirely sitting inside the circle like this. Okay, again in this case also no common tangents possible. So in these cases we cannot talk about this angle. Fine. Okay. Next interesting case is r is between b and a, b less than r less than a. So in this case the situation will be like this. Okay, circle and ellipse, they look like this. Now if you take this common tangent, this sky blue line, okay, this is a common tangent to both the circle and ellipse. Okay, now let the common tangent makes an angle theta with a positive x-axis. Okay, so here this common tangent making certain angle theta with a positive x-axis. Okay, now let us take this common tangent equation in normal form. Okay, let the equation of the tangent be x cos alpha plus y sin alpha equal to r, normal form. Here r is the length of the perpendicular from 0, 0 to this line, and alpha is the angle that this perpendicular making with positive x-axis. Fine. What should be the connection between this theta and alpha? Since we have a right angle here, okay, so theta must be equal to pi by 2 plus alpha. Okay, here we have theta equal to pi by 2 plus alpha. If you consider this common tangent to the circle and ellipse, then this is going to be theta. Okay, then alpha is going to be, this is going to be alpha. Okay, fine. And again, this one is r. In this case, the connection between theta and alpha will be this. Theta equal to alpha minus pi by 2. Okay, both relations will lead to the same theta. So let me go ahead with this one. Fine. Okay. Now this line x cos alpha plus y sin alpha equal to r will be obviously tangent to the circle x square plus y square equal to r square, because distance from the center to this line is what, r, which is exactly radius of the circle. So this line must be touching the circle. So we can say that x cos alpha plus y sin alpha equal to r obviously tangent to the circle x square plus y square equal to r square. And we want this line also to be tangent to ellipse. Okay. Okay. If you compare this line with Lx plus My plus n equal to 0, okay, L will be cos alpha, M will be sin alpha, and n equal to minus r. Okay, we know the condition for Lx plus My plus n equal 0 to be a tangent to the ellipse x square by a square plus y square by b square equal to 1. That is a square L square plus b square m square equal to n square. Okay, that's why we should have here a square cos square alpha plus b square sin square alpha equal to r square, right? That's why we should have a square cos square alpha plus b square sin square alpha equal to r square, since this one is also tangent to the ellipse. Fine. Now using this relation we can write alpha equal to theta minus pi by 2. So if I replace alpha with a theta minus pi by 2, then we have this a square cos square of theta minus pi by 2 plus b square sin square of theta minus pi by 2 equal to r square. Now cos theta minus pi by 2 will be same as sin theta, and sin theta minus pi by 2 will be equal to minus cos theta. But since we have a square, so in this case this is going to be equal to sin square theta. This is going to be equal to cos square theta. So we have a square sin square theta plus b square cos square theta equal to r square. Now let me replace sin square theta with 1 minus cos 2 theta by 2, cos square theta with 1 plus cos 2 theta by 2. Now this thing gets simplified to this a square plus b square minus a square times cos 2 theta equal to 2r square. Feel free to verify this. Now next we can write cos 2 theta equal to a square plus b square minus 2r square by a square minus b square. Okay, because first you can write b square minus a square times cos 2 theta equal to 2r square minus of a square plus b square. Okay, next we can write cos 2 theta equal to, so in the denominator and the numerator if you get the minus out, then you can write a square plus b square minus 2r square by a square minus b square. Okay, that's for this one. Okay, cos 2 theta. So we can write theta equal to cos inverse of a square plus b square minus 2r square by a square minus b square. This is going to be theta. Okay. So the angle that common tangent to the circle x square plus y square equal to r square and the ellipse x square by a square plus y square by b square equal to 1 makes with a major axis of the ellipse is of cos inverse of a square plus b square minus 2r square by a square minus b square. Okay, this is going to be theta. Okay, now we are left with two more cases, that is r equal to a or r equal to b. Okay, so if r equal to a, then the common tangents would be two vertical lines x equal to a, x equal to minus a. Okay, in this case, so the theta will be what? So in this case, the theta will be pi by 2. Okay, fine. If r equal to b, then the common tangents would be two horizontal line y equal to b and y equal to minus b. So this is a one common tangent, this is another common tangent, both are horizontal line. So the angle this horizontal line making with the x-axis would be 0. So in this case theta will be 0, in this case theta is pi by 2. Okay, if r equal to a, so the angle theta is going to be pi by 2. If r equal to b, the theta is going to be 0. Fine. Okay. Next, problem 2 from section 1 of the exercise 4b. Find the equation of tangent and normal to the ellipse x square plus 2y square minus 4x plus 12y plus 14 equal 0 at the point 2 comma minus 1. Okay. First, let us find out the slope of the tangent. What is our ellipse equation here? X square plus 2y square minus 4x plus 12y plus 14 equal to 0. Okay. Now differentiate with respect to x. Okay. What you get? 2x plus 4y dy by dx minus 4 plus 12 dy by dx plus 0 equal to 0. So if you group dy by dx term, now let me take 4 dy by dx common, then we have y plus 3 that equal to, if I take minus 4 to x that side, I can write 4 minus 2x. So this we can write dy by dx equal to 2 minus x by 2 times y plus 3. Okay, so dy by dx at the point 2 comma minus 1 is going to be 2 minus 2 by 2 times minus 1 plus 3, it's going to be 0. So the slope m, which is the slope of the tangent, okay, at 2 comma minus 1 is 0. Okay, so the tangent will be horizontal line passing through 2 comma minus 1. Okay, so the tangent will be what? Tangent, the line passing through 2 comma minus 1 having the slope 0, means you will write y minus of minus 1 equal to 0 times x minus 2, that implies y plus 1 equal to 0. Okay, which is the horizontal line. Then what will be the normal? Normal will be vertical line passing through 2 comma minus 1. Okay, so the normal line will be what? Vertical line passing through 2 comma minus 1 means that will be x equal to 2. That implies x minus 2 equal to 0. Okay, fine. Okay, okay. If you see this ellipse equation as s equal to 0, this one as x1, y1, then you can also say tangent is s1 equal to 0. Okay, so if you compare this one with ax square plus by square plus 2gx plus 2fy plus c equal to 0, what would be s1? S1 will be AXX1 plus BYY1 plus G times X plus X1 plus F times Y plus Y1 plus C equal to 0. Okay. So what is A here? Here A equal to 1, B equal to 2 and G equal to minus 2, F equal to 6, C equal to 14. So what will be this? And x1 y1 is 2 comma minus 1. Let's see. So in this case S1 will be 1 times x times 2 plus 2 times y times minus 1 plus minus 2 times x plus 2 plus 6 times y minus 1 plus 14 equal to 0. What will be this? We have a 2x minus 2y minus 2x minus 4 plus 6y minus 6 plus 14 equal to 0. As you can see, this 2x cancel. Minus 2y plus 6y, we have a 4y minus 10 plus 14, it will be plus 4 equal to 0, that is y plus 1 equal to 0. Okay, you can also get tangent like this. Okay, here you can also get tangent as s1 equal to 0. Once you get a tangent, you can see the slope of the tangent, then you will know what is the slope of the normal. Then you can also write down normal equation. Okay, fine. Next, problem 3 from section 1 of the exercise 4b. Find the equation of the tangents to the ellipse 9x square plus 16y square equal to 144, which makes equal intercepts on the coordinate axis. First, let me write down given ellipse equation in standard form. Simply let us divide both sides by 144. Then we end up with the equation x square by 16 plus y square by 9 equal to 1. Let me call it 1. Here a square equal to 16, b square equal to 9. So we have a greater than b case. Fine. Okay. We know that any tangent to the standard ellipse x square by a square plus y square by b square equal to 1 will be in the form y equal to mx plus or minus under root a square m square plus b square. Okay, so we can write down any tangent to 1 will be in the form y equal to mx plus or minus under root a square m square plus b square. What is a square here? 16 m square plus b square, that is 9. Okay, let me call it 2. Let me write down 2 in intercept form. Okay, so 2, let me write mx plus y equal to plus or minus under root 16 m square plus 9. So let me write down x by plus or minus 16 m square plus 9 by minus m plus y by plus or minus under root 16 m square plus 9 equal to 1. Okay. Okay. Here x intercept going to be plus or minus under root 16 m square plus 9 by minus m, and y intercept going to be plus or minus under root 16 m square plus 9. Okay, now we are looking for tangents which makes equal intercepts with a coordinate axis. Okay, so that means we have to look for values of m for which x-intercept equal to y-intercept. Okay, let's make x-intercept equal to y-intercept. Okay, x-intercept equal to y-intercept, that is plus or minus under root 16m square plus 9 by minus m equal to plus or minus under root 16m square plus 9. Here these two get cancelled. Then we will have minus m equal to 1, that implies m equal to minus 1. Okay. Therefore, tangents that make equal intercepts with coordinate axis are y equal to, what is the m value, minus 1 x plus or minus under root 16 minus 1 whole square plus 9. Okay, this gets simplified to x plus y equal to plus or minus root 25, that is 5. Okay, these are the tangents to the given ellipse which makes equal intercept with a coordinate axis. Okay. Next, problem 4 from section 1 of the exercise 4b. Find the coordinates of the points on the ellipse x square plus 3y square equal to 37 at which the normal is parallel to the line 6x minus 5y minus 2 equal to 0. Okay. First of all, let me write down given ellipse equation in standard form. It will be x square by 37 plus y square by 37 by 3 equal to 1. Here a square will be 37, b square will be 37 by 3. Fine? Okay. And given line equation is 6x minus 5y minus 2 equal to 0. Okay? Fine. Now, let us say this is the given ellipse and let us say this is the given line. In this problem, we are looking for a point on the ellipse at which normal should be parallel to given line. So this may be the point, okay, at which the normal is parallel to the given line. If that is the case, tangent at that point should be perpendicular to given line. Okay, fine. So what is the slope of the given line? That is 6 by 5. Then what should be the slope of this tangent? As it is perpendicular to given line, m value should be minus 5 by 6. Okay. Now this point can be realized as point of contact of this tangent to this ellipse whose slope m equal to minus 5 by 6. Okay. We can actually answer this point of contact in terms of the slope and AB. We know that point of contacts to the ellipse x square by a square plus y square by b square equal to 1 with a slope m or minus a square m by under root a square m square plus b square by under root a square m square plus b square. This is a 1. Other one will be a square m by under root a square m square plus b square comma minus b square by under root a square m square plus b square. Okay. Here a square value 37, b square value 37 by 3 and m value minus 5 by 6. Okay. First let us see under root a square m square plus b square value. Okay. It's going to be under root a square value 37 and m square value will be 25 by 36. Okay. Plus b square value 37 by 3. Okay. Now under root, so it will be 37 times 25 plus 12 times 37 by 36. So it's going to be under root 37 times 37 by 36. It will be 37 by 6. Okay. Fine. Okay. Now a square m by under root a square m square plus b square value will be a square m. What is a square? 37 times m minus 5 by 6 by under root a square m square plus b square value. We got 37 by 6. So here 37 cancel, 6 cancel. We got minus 5. Okay. Similarly, b square by under root a square m square plus b square value going to be, what is b square? 37 by 3 and under root a square m square plus b square value we got 37 by 6. So this will be equal to 2. Therefore, the point of contacts will be point of contacts. The first one will be minus of minus 5, that is 5 comma 2, and the next one will be this one minus 5 comma minus of 2, that is minus 2. Okay. So these are points on ellipse at which normal will be parallel to given line 6x minus 5y minus 2 equal to 0. Fine. Next, problem 2 from section 2 of the exercise 4b. Find the equations to the tangents to the ellipse x square plus 2y square equal to 3 drawn from the point 1 comma 2 and also find the angle between these tangents. First of all, let me write down given ellipse equation in standard form. First of all, let me write down given ellipse equation in standard form. X square by 3 plus y square by 3 by 2 equal to 1. Here a square equal to 3, b square equal to 3 by 2. Okay. Fine. You can easily check that the given point 1 comma 2 exterior to the given ellipse. So we will have two tangents passing through 1 and 2. So we have to find out these tangents and we also have to find out angle between these two tangents. Fine. Okay. We know that any tangent to the ellipse x square by a square plus y square by b square equal to 1 will be in the form y equal to mx plus or minus under root a square m square plus b square. So our required tangent can be taken in the form y equal to mx plus under root a square m square plus b square in this case. So tangents through 1 comma 2 can be taken in the form y equal to mx plus under root a square m square plus b square. That is, tangent will be in the form y equal to mx plus, here a square is 3, b square is 3 by 2, under root 3m square plus 3 by 2. Fine. Okay, let me call it this one 1, this one 2. Okay, now here 2 is passing through the given point 1 comma 2. So we should have 2 equal to m times 1 plus under root 3m square plus 3 by 2. Okay, that implies if I bring m this side and take a square both sides, then I can write 2 minus m whole square equal to 3m square plus 3 by 2. So we will have 4 plus m square minus 4m equal to 6m square plus 3 by 2. So after cross multiplication I can have 8 plus 2m square minus 8m equal to 6m square plus 3. So if I take one side I can write 4m square plus 8m minus 5 equal to 0. Then I can write 4m square. This 8m let me write like 10m minus 2m minus 5 equal to 0. Then if I take a 2m common, then we have a 2m plus 5 minus 1 common, 2m plus 5 equal to 0. That implies 2m minus 1 times 2m plus 5 equal to 0. That implies m value 1 by 2 and m value minus 5 by 2. For a given ellipse, there will be two tangents that are passing through given point 1 and 2. One having the slope m equal to 1 by 2, other having the slope m equal to minus 5 by 2. M equal to 1 by 2 will give you the tangent y equal to 1 by 2 times x plus under root 3 times 1 by 2 whole square plus 3 by 2. So this will be simplified to y equal to x by 2 plus root 9 by 4. Then we can write x minus 2y plus 3 equal to 0. This is a one tangent. Okay. This is a one tangent whose slope is 1 by 2. For m equal to minus 5 by 2, then the corresponding tangent will be y equal to minus 5 by 2x plus 3 times 5 by 2 minus 5 by 2 whole square will be 25 by 4 plus 3 by 2. This will be y equal to minus 5 by 2x plus under root. So it will be 75 plus 6, 81 by 4. So it's going to be 5x plus 2y minus 9 equal to 0. Okay. So 5x plus 2y minus 9 equal to 0. Another tangent having the slope minus 5 by 2. Let me call m1 equal to 1 by 2, m2 equal to minus 5 by 2. Okay. Fine. Now let us find out angle between these two tangents. Now the tan theta formula I can write in terms of these slopes. Mod m1 minus m2 by 1 plus m1 m2. It's going to be m1 is 1 by 2 minus of minus 5 by 2 by 1 plus 1 by 2 times minus 5 by 2. So this is going to be 6 by 2 by 1 minus 5 by 4. Okay, it will be, so this will be simplified to 12. So therefore theta equal to tan inverse of 12. Okay, so this is the angle between two tangents. Fine. Next, problem 4 from section 2 of the exercise 4b. A circle of radius 4 is concentric with an ellipse 3x square plus 13y square equal to 78. Prove that common tangent is inclined to the major axis at an angle pi by 4. Here we are to show that common tangent to this ellipse and given circle, which are concentric, will be making angle pi by 4 with a major axis of the ellipse. Okay, fine. First of all, given ellipse in standard form, if you write x square by, so 78 by 3 will be 26 plus y square by 78 by 13 will be 6 equal to 1. Okay, here a square equal to 26, b square equal to 6, so we have a greater than b case. Fine. Next, circle of the radius 4 that is concentric with a given ellipse will be this one, x square plus y square equal to 16. Okay, both having center 0 0. Let me call this one 1, this one 2. Okay, this ellipse and this circle look something like this. Okay, let us say this is the x-axis, y-axis. This is the ellipse. Okay, then this is going to be a circle something like this, and the common tangent to these two, okay, will be making certain angle theta with the major axis, that is x-axis here. Okay, from the solved problem 7 we have a formula for this theta in terms of a square, b square and r square. Here what is the r square? It is 16. First of all, here we have b less than r less than a case. So in this case the theta is going to be half cos inverse of a square plus b square minus 2r square by a square minus b square. This is the formula when we have b less than r less than a. That is the case here, because r value 4, b value root 6, a value root 26. Okay, so now the theta equal to half cos inverse of, what is a square? 26 plus b square, that is 6, minus 2 times r square, that is 16, by 26 minus 6. So this is going to be half cos inverse of 32 minus 32, that is 0 by 20, that is half cos inverse of 0. Cos inverse of 0 is pi by 2, so pi by 4. Therefore the theta we got pi by 4. Okay, so this angle is going to be what? Pi by 4. So the common tangent to this given ellipse and concentric circle with a radius 4 making an angle theta with a major axis of the ellipse. Fine. Next, problem 1 from section 3 of the exercise 4b. Show that the foot of the perpendicular drawn from the center on any tangent to ellipse lies on the curve x square plus y square whole square equal to a square x square plus b square y square. Fine. Okay. Let us consider standard ellipse here. Let ellipse equation is x square by a square plus y square by b square equal to 1. Okay. Let us say this is our ellipse. Okay. Center is 0, 0. Now, if I draw tangent at this point, let us say this is a tangent, then the foot of the perpendicular from this center to this tangent will be somewhere here, let us say h comma k. Now I have to show that locus of this point h comma k will be this curve x square plus y square whole square equal to a square x square plus b square y square. Fine. Okay. First of all, so the CP, let us say this point P, the CP slope will be what? K minus 0 by h minus 0, that is k by h. Then slope of the tangent at P will be what? Minus 1 by slope of this CP, that is minus 1 by k by h will be equal to minus h by k. So, what should be the tangent equation? The tangent equation at point P will be what? Line passing through h comma k having the slope minus h by k. Okay, that will be y minus k equal to minus h by k times x minus h. Okay, so if you simplify, okay, now let me write down this line in slope intercept form. Y equal to minus h by k x plus h square by k plus k. Let me write further, y equal to minus h by k x plus h square plus k square by k. So this look like a y equal to mx plus c. Okay, so this is m, this is c. Okay, let me call this one 1, this one 2. This 2 is what? Tangent to the 1. So here 2 is tangent to 1. That happens only when c square equal to a square m square plus b square. Okay, so we should have c square means h square plus k square by k whole square equal to a square m square. A square, what is m here? Minus h by k. So that is m. So a square minus h by k whole square plus b square. Since we should have c square equal to a square m square plus b square. Okay, fine. Now it's giving what? H square plus k square whole square by k square and a square h square plus b square k square by k square. Then k square cancel. So we have h square plus k square whole square equal to a square h square plus b square k square. Okay. Therefore, locus of P, the point ph comma k is what? X square plus y square whole square equal to a square x square plus b square y square. Okay, fine. Okay, let me stop here. We have finished ellipse chapter. Thank you.